We've already talked about what domain and range means, so now we're going to talk about what a function is and what that looks like and what a function means, and how we can figure out if something is a function. You've definitely done this before in sophomore year math and in freshman year math. You definitely know how to figure out what a function is, but I think it's important that we go over it and make sure we're all on the same page. So the textbook that we use, right, we draw these little function machines, right? So we call this like a little function machine, and it's a nice way to illustrate what a function is doing. So essentially we're plugging in a number and we're getting a number out. And so what happens in the middle is what's going on in the function machine. So the numbers that we plug in x values every single time, no matter what, to a function. And last class, we talked about x values being our domain. So another way we can think about this is that the x values we plug in, right, that's our domain. That's the numbers we're allowed to plug in. So we plug in the x values, aka the domain, aka the independent variable. Because the x value doesn't depend on anything else, right? The values that we get out depend on what we put in, but what we put in doesn't depend on what we get out, if that makes sense, right? Like we can put in any number and we'll get a number out, but it doesn't matter what number we put in, right? The number we get out depends though on the number that we put in, right? So when we talk about what we put into the function machine, we're talking about x values, the domain, independent variable. And then when we're talking about what we get out of the function machine, we're talking about y values. And we learned that that's also range, right? So domain, right, is how wide something is, what x values we cover, and range is how tall something is, what y values we cover. And again, another way we can talk about range is by calling it our dependent variable. So essentially, a function is a relationship with one or more variable where each input has a single output. Right? So a function is a relationship with one or more variables where each input has a single output. And so we can think of output as our y values and input as our x values. And so we're going to repeat this again because this is really important, and this is how we define what a function is. Each input is only allowed to correspond to one output. So if I plug in a 7 and I get an 8 out, the next time I plug in a 7, I better get an 8 out, otherwise it's not a function. So each input is only allowed to correspond to one output. And so when we look at tables, right, or graphs or anything visually, it's really helpful to look at all the x values. And so I can see that I have x values 0, 1, 2, 3, and 4. And so each input, right, my x values is unique. 0 does not equal 1, 1 does not equal 2, so on and so forth, right? We don't have any repeating x values. And so because we don't have any repeating x values, I know that this is a function. So because no repeating x values, definitely a function. So then when I look at my next table, I see that I have two x values that are the same. I have two -3s. And so the first time I plug in a -3, I get a 1 out. So then the next time I plug in a -3, I should get a 1 out. But in this case, I get a -1 out. So because the 1 and the -1 don't match, this cannot be a function. I can't plug in a -3 and get a 1 and a -1 out. That doesn't work. So when you look at a table or when you look at a set, right, of numbers and you see the domain and the range, if you have repeating x values and the y values that associate with them are different, then it's not a function. And so we've also learned in classes, and I think we talked about this in the last set of notes, that if I have a graph and it looks like that, and I'm determining if it's a function or not, I can use the vertical line test to see how many times the vertical line hits the function or hits the graph, right? And so if it hits it one time, it is a function. If it hits it more than one time, it's not a function. So when we look over here, it hits it 1, 2, 3 times. And what that's saying is at that x value, I could get 3 different y values out. Just like at this table when we plugged in a -3 and I got a 1 and a -1 out, right? So when we do the vertical line test on a graph, that's saying, well, if I plug in this x value, I could get 3 different y values out. But a function, if I only plug in one x value, I should only get one y value out. I can't get multiple y values associated with one x value. So the table and the vertical line test are really saying the same thing. They're just different ways of looking at it. And then we have a little bit of important notation that we got to talk about. And so when we're dealing with a function, we use this symbol, right? We have an f and then some parentheses, an x, close the parentheses, in place of y. So when we're talking about a function, we don't use y, we use f of x. And so when we say that out loud, we say f of x, and that's what that symbol means. And then in addition to kind of reviewing the notation, we should know how to plug numbers in, how to evaluate a function, right? So to evaluate a function for a particular x value, we just plug in and then simplify, right? So this problem below, it says find f of 3. So I take that 3 and every time there's an x, I plug in a 3. And so I end up with 6 minus 1, which is 5. So whenever we're evaluating a function, we plug in the number that we're given, right? So in this case, it said find f of 3. So anytime there's an x, I now plug in a 3. So hopefully this cleared some stuff up on functions, and this will help you on some IXL problems. It will help you for the quiz, and hopefully this helped you fill out your guided notes.